In the previous video, we deployed a Node.js app on a single EC2 instance on a single availability zone. But this deployment has an issue, which is availability. If the instance or the availability zone goes down, the app would be unavailable. To fix this issue, in this video, we are going to deploy our app on multiple availability zones. In the new design, we have two EC2 instances deployed on two availability zones. We call those EC2 instances targets. We use a load balancer to distribute traffic to both instances. The load balancer listens to HTTP traffic on port 80 and delivers traffic to targets on port 8080. In the previous video, when we accessed the app on the browser, we appended the port number. Because now the load balancer listens on port 80 and the browser uses port 80 by default, we don't have to specify the port number on the browser. Before start configuring, let's talk about each component of a load balancer. Targets represents EC2 instances. Targets are associated with target groups. Target groups are then associated with the load balancer. Within the load balancer, a rule can be defined to route different traffic into different target groups. In our system, we will be using only one target group. Also note that the most common load balancer type is the application load balancer, which we will be using. When configuring the system, we are going to follow these steps. Step 1. Creating an AMI based on the instance created in the previous video. Step 2. Launching the second instance by the created AMI, then connecting to it and starting the server. Step 3. Creating load balancer security group. Step 4. Creating a target group, then registering the two instances. Step 5. Creating a load balancer. Step 6. Testing the load balancer. Now let's start with the first step, creating an AMI. In the previous video, we launched an EC2 instance and we deployed our app on it. When creating the second instance for our load balancer, we have two options. Option 1. Launch and configure another EC2 instance similar to the previous video. Option 2. Creating a copy of the previously created instance and launching a new instance using the copy. We are going to use option 2, which is creating a copy. We call a copy of an instance an image, Amazon Machine Image or AMI. Let's navigate to the EC2 console and click on the Instances tab. Then select the previously created instance. Click Actions. Go down to the Image and Template section. Click Create Image. Enter image name. I will enter Web Server Image as my image name. Enter a description. Then go down to the bottom of the page and click Create Image. Then go to the AMI section and observe that the image has been created. Next, we are going to go to the step 2, which is launching an instance by the created AMI. On the EC2 console, go to the Instances tab and click on Launch Instance. Enter instance name. I will enter Web Server 2 as my instance name. Go down to the Applications and OS Images section and click on My AMIs tab. Then select the previously created image. Go down to the Instance Type section and select T2 Micro as the instance type. Select the previously created key pair. Go down to the Network Settings section and click Edit. Click on the Subnets drop-down. I selected US West 1B as my subnet because my first instance is on US West 1C. Select the previously created Web Server Security Group. Then click on Launch Instance. Then go back to the instances section and observe that the instance creation is pending. Also observe that our two instances are in two different availability zones. Because the instance was created by using an image of previously configured EC2 instance, we don't have to configure it again. Our Node.js app should already be there. But we are going to connect to the second instance and confirm that our app is already there. Select Web Server 2 instance, click Connect, and go to the SSH tab and copy the SSH URL. Open the terminal and navigate to the folder where you have .pem file. Paste the URL. If the username of the URL says root, change it to ec2-user. Press enter to connect. Execute the ls command and observe that our Node.js app is already there. Within the simple node server folder, run the command pm to start index.js to run the Node.js server. Next, we are going to access the second instance directly and test if it is working. Click on the Web Server 2 instance and copy the public IP address. Then open your browser and paste the URL. Make sure to append the port number 8080. Because our Node.js app is listening on port 8080. You should see Hello World on the page. We just completed step 2. Now we are going to go to step 3, which is creating the load balancer security group. On the EC2 console, go down to the security group section. Click on Create Security Group. Enter the security group name. I will enter Load Balancer Security Group as my security group name. Enter a description. Select the default VPC, then go down to the inbound rules section. Click Add Rule and allow HTTP traffic from anywhere. Then go down to the outbound rules section and leave the default rule which allows all traffic to anywhere. Click Create Security Group and observe that security group has been created. That completes step 3. Now we are going to step 4, creating a target group and registering 2 instances. Scroll down to the target group section. Click Create Target Group. Keep instances as the target type. Enter target group name. I will enter Web Server Target Group as my target group name. Update target group port to 8080. Then go down to the health check section. Leave the health check port and path unchanged. Within the advanced health check settings section, change the health check port to 8080. Then reduce the health check interval to 10 seconds. Click Next. Now we are going to register the targets. Select the previously created 2 EC2 instances. Then click Include as pending. Click Create Target Group and observe that the target group has been created. Now we are going to go and create our load balancer. Go down to the load balancer section. Click Create Load Balancer. Click Create Application Load Balancer. Enter load balancer name. I will enter App Load Balancer as my load balancer name. Leave internet facing because we want to access our load balancer over the internet. Select 2 availability zones that we use to launch our 2 EC2 instances. Select the load balancer security group that we created before. Go down to the listeners and routing section and select the previously created target group. Then click Create Load Balancer. And observe that the load balancer has been created. The load balancer is in the provisioning status. That concludes step 5. Now we are going to go to step 6, which is testing the load balancer. On the EC2 console, go down to the load balancer section, select the load balancer, and make sure the status is active. From the details section, copy the DNS name. Open the web browser and paste the copied URL. Pressing enter should display Hello World on the page. Notice that we didn't have to append the port number 8080 to the URL because the load balancer is listening on port 80. Let's review our system. We have two EC2 instances running on two availability zones. The load balancer is distributing traffic between both instances. If one instance goes down, the application should still be available because there is one more instance running. Let's go ahead and stop one instance and see what will happen. Select the first instance, click on the instance state drop-down, click Stop Instance. Wait until the instance status is stopped. Then open the browser and refresh it. You will still see the Hello World message because there is still one more instance running. Next, let's go ahead and stop the second instance and see what will happen. Wait till the status of the second instance is also stopped. Open the browser and refresh the browser. Notice that the browser will eventually time out. That's because there are 0 instances in our system. At the end of the project, make sure to delete the load balancer target group and EC2 instances so that you will not get additional charges. In this video, we learned that the availability of a system can be improved by launching multiple EC2 instances on multiple availability zones and distributing traffic to them by using a load balancer. But this architecture still has an issue, that is scaling. We are going to talk more about scaling in the next video.